By early 2026, China's tech sector was hollowing out. A fierce deflationary cycle forced massive layoffs across the industry, and thousands of highly skilled product managers and software engineers suddenly found their desks cleared out, left without a steady paycheck or a corporate safety net. For these displaced workers, the immediate instinct was to pivot toward digital freelancing. To compete as a one-person operation, you need artificial intelligence to handle the heavy lifting of coding, research, and marketing. But relying on enterprise-grade cloud AI means paying for continuous API subscriptions, essentially renting computing power by the prompt. When you have zero income, ongoing operational expenses, or OPEX, are lethal. Those monthly recurring charges for cloud access quickly drain whatever severance or savings a displaced tech worker has left, pricing them completely out of the very tools they need to achieve hyper-productivity. The exact people whose economic survival depended on high-level automation found themselves locked out. The algorithms existed, but access was an unaffordable luxury. In 2025, giants like Samsung overestimated enterprise demand, scaling aggressively for AI servers. By 2026, new fabrication plants came online just as demand cooled, creating a massive bullwhip effect. Excess capacity flooded the market, plunging retail prices for consumer DDR5 memory by 60%. Top-tier 128GB memory configurations, a setup previously restricted to wealthy enthusiasts and high-end research labs, were suddenly sitting on retail shelves for $150. This global supply chain miscalculation accidentally handed millions of out-of-work professionals a massive windfall. They now had the cheap, raw computing material required to run advanced AI entirely on their own machines, completely bypassing those expensive cloud subscriptions. Enter OpenClaw. Released in early 2026, OpenClaw is an open-source AI agent framework that moves artificial intelligence away from just generating chat responses. Instead, it acts like a digital employee, autonomously taking control of your operating system, calling external tools, and executing complex tasks across multiple platforms without you holding its hand. But running a fully autonomous agent is entirely different from pinging a chatbot. OpenClaw needs to maintain massive, ongoing context windows and continuous logs of every tool it uses. Keeping all those thought processes active requires an enormous amount of local RAM. Think of RAM as physical disk space. You can only hire as many digital workers, these agent blocks, as you have memory to seat them. Users fill this space with local knowledge bases, feeding data to the agents, a practice the Chinese dubbed raising shrimp. With DDR5 memory suddenly dirt cheap, users could afford enough RAM to load these agents and their data entirely offline. The agents could comb through personal emails, proprietary code, and sensitive files with total privacy, never pinging an external server. The limiting factor for building a digital workforce was no longer a lack of advanced intelligence. It was strictly a matter of physical memory capacity, which you could now buy in bulk for the price of a nice dinner. The shrimp farmers quickly developed a specific hardware playbook.
Because OpenClaw requires total, highly privileged access to a system to do its job, users refuse to install it on their primary computers. Instead, they bought dedicated hardware, physically isolating their personal data from the autonomous AI. The ultimate tool for this became the Apple Mac Mini. Its unified memory architecture delivers over 120 gigabytes per second of bandwidth, allowing local, lightweight AI models to run incredibly smoothly, without the user having to purchase an expensive, dedicated graphics card. Beyond bandwidth, these machines offer extreme power efficiency. Drawing only 5 to 7 watts of power while idle, a dedicated Mac Mini can sit in a dark room, its power indicator pulsing steadily, running an entire digital workforce completely autonomously, 24 hours a day, 7 days a week, without spiking the electric bill. By utilizing this hardware, displaced workers converted a recurring software tax into a single upfront purchase. They took the operating expense of cloud computing and turned it into a one-time capital expenditure. Displaced IT workers used this hardware strategy to replace the functions of entire junior departments, operating as hyper-efficient, resilient one-person companies. While this hardware boom offered a lifeline to individuals, it also exposed a massive vulnerability in how society handles data. When we rely exclusively on centralized, cloud-based AI systems controlled by a few massive corporations, we hand over immense unchecked power.
Consider the 2026 Angela Lips case. A grandmother was sent to jail for 6 months simply because a centralized facial recognition system misidentified her. A closed-source algorithm made a mistake, and a citizen lost half a year of her life. You can see the problem in this graphic. A glowing 98% match overlay completely obscuring the actual mismatched fingerprint and location files underneath. This is automation bias. The authorities blindly trusted the centralized algorithm's high confidence score over actual contradictory physical evidence. Centralized AI monopolies price out the working class and threaten individual liberty when their hidden algorithms inevitably fail. The same 128-gigabyte workstations used for raising shrimp effectively became the first line of defense against these centralized algorithmic errors. Developers began releasing platforms like Nexus Crime AI. Instead of relying on one massive cloud server, Nexus utilizes multiple independent agents running directly on a user's local machine to cross-reference legal precedents and geographic data, completely outside the control of any central authority. Because 128 gigabytes of RAM is now incredibly cheap, anyone can download the data and run these independent verification agents themselves. If an institutional AI makes a claim, an individual can instantly audit, cross-check the facts, and challenge that output locally. This graphic shows a single geometric node processing data lines, but as we zoom out, you see an entire interconnected web. The personal computer has evolved from a simple word processor into a powerful independent node in a decentralized network of truth verification. The 2026 memory crash pulled white-collar workers out of poverty and decentralized AI, placing the power to process truth directly on the desks of everyday citizens.